Hello, Tom. Today we are going to talk about scientific models and how good are they. When you look at scientific models, what are the questions that you want answered from each of them? How do you determine the better model?
Okay, well, all of scientific theory are models. And we no longer have any scientific laws, even though we'll still call Newton's laws, but that's just historical. Newton's laws aren't really laws either because they don't work all the time. They only work in certain regions of our reality, certain low speeds and smaller sizes. The higher speeds require relativity, and the smaller sizes require quantum mechanics. So physicists long ago decided that there were no laws because we don't know what new data might come in the future to prove what our theories are now to not be complete. There's something more that needs to be added to it. It's not so much that our theories are necessarily going to be proved wrong. Newton wasn't proved wrong so much as Newton was just proved to only hold as an approximation within a certain realm of physical reality. And now we're going to see that the rest of science is going to be held to only apply in a certain realm of the larger reality. It's sort of the same thing happening again, where we look at our physical science, and that physical science is only going to represent part of our reality because our reality will be bigger than the physical. So you'll have the science of objective objects and the science of subjective information. So objective and subjective information will both be scientific. And right now, we deal with scientific subjective information in medicine all the time. You deal with that with statistics. It's not that a thing just is, but you have to experiment with it and do trials and see how its effect is, because when it's dealing with medicine, you're dealing with something that doesn't have a single answer. Our biology is so diverse that there's so many different people. To just say, well, if you take this pill, your headache will go away, is never going to be true. There'll be somebody who will take that pill and it won't make their headache go away. You see, because our biology is just that diverse. So the subjective world can be scientific and logical, just like the objective world can be scientific and logical. One just uses statistics as its measure of quality, or its measure of goodness, its measure of rightness. We call that statistical significance. So anyway, back to the original question, everything is a model. So relativity is a model, quantum mechanics is a model, okay? Newtonian physics is a model. And models are judged solely by what they deliver, because we no longer believe that this model is the only truth that will ever be, because there's a lot of years yet to go, before the sun expands and our solar system goes away and the universe turns into hydrogen gas and elementary particles. And in that time, we're going to find out all kinds of things that may make what we believe now just a small part of something bigger. So with that knowledge, we talk about our model. So the model of quantum mechanics and the model of relativity have some problems with each other. Each one has an assumption that the other denies. So there's a little bit of a philosophical argument, though both do marvelously well in the area in which they work. Okay, so that's been a thing that Einstein started and others are still working on, is trying to bring those two together under one understanding. Because if you have two things that are incomplete because they don't describe everything, they just describe a part of something, then there's something bigger that's more fundamental that would describe them both. So that was what Einstein called his toe. his theory of everything. He was going to derive quantum mechanics and relativity from one understanding. He didn't make it. He spent the last 20, 25 years of his life working on it, along with a lot of others, and he came up empty-handed. He had problems, and we have some quotes from him that have been in some of my talks where he says, "I know that consciousness plays a key part here." And he knew that from quantum mechanics. But he says that he had no idea of the fundamental concepts that he could use to derive a theory. You know, the theory in his mind, of course, had to be mathematical, which is true, or logical, and he needed some place to start, something to start with. And consciousness was just this undefined thing that was very difficult to turn into objective science. So he was kind of stuck there. And so have been all the physicists stuck until we look at the concept of virtual reality. And then when we have the concept of virtual reality, this is not a physical reality, then it's not that hard to derive quantum mechanics and relativity from the perspective of virtual reality and solve that big toe. But the virtual reality solves a problem much bigger than the toe that Einstein was looking for, because now that virtual reality opens up a whole nother piece of reality that wasn't included in Einstein's work. Because if you have a virtual reality, the virtual reality has to come from some other reality other than this reality. You know, and you can go read some of Fredkin's work. It was one of his fundamental points, and it's just almost baby logic. You know, a reality can't create itself because it didn't exist to create itself. So it's a simple logic problem that a simulation has to be simulated elsewhere. And Fred could call that elsewhere other, someplace other than within this reality. So it's outside of this reality, which makes it appear non-physical to us. Okay, so now when you have that bigger picture, that our physical reality is information-based, which means that it is a computed reality, a simulated reality. With that comes the concept that there's another part of our reality that is non-physical to us, that is more fundamental than our virtual reality. It's the creator of our virtual reality, if you will. So that's why the virtual reality viewpoint has what it takes to describe both quantum mechanics and relativity, because it comes from one step higher up on the, conceptual ladder. It's bigger than both of those. Both of those are just centered in this what we call the physical reality, which is a computed reality. So when you get something that's from the next echelon up, then you can find an explanation for the things that are kind of on the echelons below that. So that's why virtual reality is the thing that will explain both quantum mechanics and relativity. It's just a fundamental logic that it's got the right stuff. So now that brings me back to the original question. A model is just a set of ideas about the way you think things work, the way that somebody thinks things work. And that model is only as good as it is in describing and explaining the things that we know, the things that we can experience. So if a model explains our experience, and let me say that differently, if it explains our facts, the things that we know that have happened to us, that we measure, we measure things. And we know, according to Newton, that, the force equals, mass times acceleration, and that's the way things work. So that's a fact. Now it's a fact within the limits of that model. That model doesn't do things that are very fast. It doesn't do things that are very small, but within its limitations, that's a fact of Newtonian physics. That means it's an approximation within that model. So Newton's model gets 3 gold stars out of 4. It misses that last gold star because it's limitations. It's not fundamental. It's not the fundamental answer that describes our reality. It just describes a piece of it, you see. But it's very good at describing a piece of it. Almost all the physics that's done outside of universities is still done with Newton's models. You know, all the physics of launching rockets and putting satellites in the air and that sort of thing, for the most part, well, maybe I'll say 99.9% of all the physics done is still Newton's physics. That's still the way we calculate things going on in our world, because Newton's area that it serves, that his model serves, is our everyday world that we live in. So his model is still dominant. We only do quantum mechanics when we're dealing with things that are very, very small, and we only deal with relativity when we deal with things very, very fast. Faster than what we normally have in our reality. So when we zing particles around in a cyclotron or in something that just spins those particles around and around and keeps making them go faster and faster, we need to deal with relativity theory, because they begin to get so fast that relativity theory starts to make corrections to Newtonian theory, you see. So a model is judged by how well it delivers the facts of our reality. Okay, now, facts tend to be personal in some sense, but facts that are on the side of objective are facts that we can agree on, because the fact that it's objective, it's an objective fact, means that all of us will see pretty much the same thing. We all agree that, you know, this brown piece of furniture is called a table, and it's made out of wood, and you can set things on it, you know, and we see it in the function, we weigh it, we measure its volume, we do the density, the density of the wood, and so on. So we can make all sorts of measurements, and everybody will agree sort of on what those measurements are. And I say sort of is because there's always error. There is no measurement that goes on for an infinite number of decimal places. There's always some error involved in a measurement. So all the measurements are, plus or minus something. So yes, if everybody wanted to measure the density of a table, everyone that did that would come up with a slightly different answer, probably in that last decimal place, that their instrumentation could actually measure. You get better instrumentation, then everybody would get the same answer until you get to that limit of that instrumentation. You see, so there's some uncertainty about everything. So there really is nothing that is actually objective in that sense, that it just is, and there is no uncertainty about it. So there really is no objective reality. We call them objective when their uncertainty is small. They're not really objective. Nobody knows exactly what that density is, because you can only measure it so well. Even if you can measure it to 20 decimal places, then you don't know what's in the 21st decimal place, you see. So we have approximate objective things in our objective reality. In the subjective reality, we always have uncertainty. More uncertainty than we have in the objective world, which also always has some uncertainty, but often very small. Okay, so when we talk about a model and I say, how good is that model? Well, how good does it explain the facts within the uncertainty that surround those facts? Okay, so let's look at two models, and we've talked about this before. We did a little talk a couple of months ago about the two different ways of viewing our physical universe being a virtual reality. And these are like two major ways, I guess. There's the dominant way, which is a way that Nick Bostrom, was the kind of the originator of that. And it says that this virtual reality is being computed by our future selves. Okay. And that each of us has our own intrinsic consciousness that's somehow, I suspect, created by our brain. And even though it's a virtual brain, it's a virtual reality, we're still talking about a virtual reality being computed But the computation is just so marvelous and so detailed and so knowledgeable, because this is, who knows, you know, tens of thousands of years in the future, where people will be a lot smarter technically than they are now. So they're so smart that they can simulate our brain, and our brain will then create the consciousness. Okay, so that is one model. And Elon Musk picked up on that model. He thinks that's a good model. And most people that talk about virtual reality end up kind of falling back into that same camp, that our future selves must be simulating this with technology beyond our imagination. And their simulation of our virtual brain allows us to create a virtual consciousness that is what we use to interact with each other in this virtual reality. And they come to that conclusion not because there's any evidence that that's the way it is. They come to that conclusion because there isn't any other explanation in their mind. They don't see any other possibility. If it's computed and we have consciousness, then they must be computing our consciousness. You see, I mean, they're doing that by computing this virtual brain, which then computes our consciousness. So each individual's walking around with their own consciousness somewhere on their person, you know, and we like to at least use the metaphor that it's in our head. Okay. Now, even if it's not in our head, even if that consciousness is created, you know, out of our heart and our bottoms of our feet and other things, that's not the point. That's kind of a trivial thing. It just goes with the body. It's a function of the body. Okay. So again, no information at all, no evidence at all that this is a fact. It's only talked about because no other possibility can be thought of. Okay, it's the only possible answer. So that's why people come to that. Well, there is another possible answer. And that model says that consciousness is the computer. The computer resides in consciousness, the computer that's computing the virtual reality. Okay, that Fredkin's other that we talked about is outside of this reality, because a virtual reality cannot compute itself. Okay, so if other is outside this virtual reality, then that makes it non-physical to us. And of course, that would be true from the other side. The other side, if we're just, if we're not avatars, but we're actually little physical things that have been computed and our consciousness has been computed with from our body, then that would also be true. The computer somewhere in the future is non-physical to us. So both of these, you know, I'm looking at two models now. So far they're both the same. They both see that there is something else that's outside of us that's computing this, and it's not in this physical reality. One says it's future us, in the future, and the other one says that this other reality, this non-physical reality, is the source itself. And we're going to call that non-physical reality the larger consciousness system. It is a system of consciousness, and you'll have to, I won't take the time to go back to, you know, how it might have begun and where it comes from and all of that, other than to say that an assumption that starts it all is that consciousness exists. So we can't deductively, we can't logically describe with any exactitude where that source comes from, because we are it. We are consciousness, and consciousness can't get outside of itself to look at its origins and beginnings. So anyway, that's the other model, is that there is this consciousness system, this larger consciousness system, and because that's an assumption, we'll just start with, and that is, which is not all that unsimilar than saying there is this future, there's this future us, okay, that is doing this, and they just are for whatever reasons. Entertainment is given in a reason, but I suspect most of us are not all that entertaining. You know, there's a few movers and shakers and maybe entertainers that are entertaining, but I suspect the 7.5 billion of us, there's probably about 99% of us don't fall into that mover and shaker category, and we're really not all that entertaining. We just get up, we go to work, you know, we come home, we watch TV, we, you know, say hello to our kids, pet the dog, go to bed, do it again the next day. You know, on the weekends we go see grandma, you know, and this is kind of life. It doesn't seem like that's really hugely entertaining, repeated over and over again. But let's say these people have a strange sense of humor and they find this reality entertaining for some reason, so they would create it, because a reality like our physical reality would take a lot of resources and a lot of effort and a lot of work to create it. And you would have to have a pretty good return on that investment to actually do it. Okay? And I just don't see that as entertainment. It doesn't make good sense to me that that's the way it works. Okay, so now we look at the other side, where consciousness exists as a system. And consciousness has a need to evolve. It's either evolve or die. Anything that exists can either keep going, you know, it can keep evolving, or if it begins to de-evolve, eventually it will de-evolve itself into non-existence. So if you look at this over the long term, you can't really be stable on the boundary. Just to stay on the boundary between those two all the time isn't likely. It's an astable situation where over the long term, it's likely that you will either de-evolve to the point that you disappear, or you will keep evolving. Okay, so that is the way this conscious system is. And in order to evolve, because it's a system of individuated units of consciousness, it's a social system. Consciousness interacts. And because it interacts, it evolves according to the quality of its choices during that interaction. And again, I'm stating these. If you want the logic behind all that, you know, go read the books or go look at some of my videos on YouTube. So then we have these individuated unit of consciousness who need a reality frame to act in, to react in, to make choices in, that has choices that are interesting, choices that help them grow, choices that help them lower their entropy and evolve. Because otherwise, they just have choices of what to tell each other and what to say, and it's a very benign environment that's very hard to grow up in, and if what you're trying to do is lower the entropy of your consciousness, which is how consciousness has to evolve. So in this system, it needed a way to create more interesting choices that matter, that had consequences, okay? Choices with consequences. That would help it evolve. It needs to evolve to stay alive. So what it does is it creates a virtual reality by coming up with the initial conditions and a rule set and letting that virtual reality evolve. And it evolves to be this virtual reality that we call our physical reality. Okay. So now we have a different situation. We have individuated units of consciousness who are playing an avatar in this virtual reality. Okay, so rather than us intrinsically creating consciousness somehow in our body, and this is done by our future selves, now we have a larger consciousness system, okay, that needs an interaction scheme that is more effective in helping it evolve. It needs choices that are significant to make. So, two different ideas altogether. One model, future selves create such intricate avatars that the avatars are conscious. Something from their avatar's body creates the avatar's consciousness. The other one is individuated units of consciousness who are part of a larger consciousness system who are playing avatars, you know, that have been evolved from a simulation that was created by the larger conscious system. So the larger consciousness system, part of it is the computer that's making the virtual reality. Another part of that larger conscious system is the players, and also, the operating system, and, the management is also there, if you will, that has to, make decisions and keep the whole thing running. So that's the two different models of us in a virtual reality. Units of consciousness, plane and avatar. Now the avatar the avatar itself is not conscious. The avatar's consciousness is its player, is its individuated unit of consciousness. In the second model, the avatar doesn't have any thoughts, doesn't have a brain, doesn't have anything. It's just a shell. It's just a shell, just like our video games. It's just something you look at that represents that character. Okay? And all the choices are made by the player, just like in our video games. All the choices are made by the player. So it's that kind of a model, just like our video games. It's got a player and an avatar. The avatar doesn't, the avatar has actually the avatar's brain is never rendered until somebody cuts open a head. When somebody cuts open a head, then the system has to render something there, and they render a brain. But that brain, that virtual brain, remembers nothing, thinks nothing, processes nothing. All the thinking and processing and remembering is going on with the player, just like in our video games, right? Your elf doesn't really remember anything or process things. It only does what the player tells it to do. The player makes all its choices. Now, the idea is with these two models, which model is the better model? So we're not going to argue, as we did the last time, the relative merits of the model as far as theory goes. We did that last time, and we pointed out the limitations and abilities of both models, basically the theory. Like, why would our future selves do this? What was the point? How would that work? And so on, and then the other model, and we compared them kind of theory to theory. Well, now I just want to look at them and say which one is the better model, which means which one answers the facts, which one can describe the facts that we find here in our reality. Okay? Now, the way I approached my model, the MBT model, wasn't to create a theory of everything really so much as it was to create a theory of consciousness. I realized that consciousness was fundamental and that the physical world was a derivative of consciousness. Okay? So I wanted to understand how consciousness worked. But if consciousness is fundamental, and if you have a good model of it, you should be able to also describe physics. The objective part of it ought to be in there too. So I spent 35 years trying to come up with what are the facts in this subjective world of consciousness. Are there any facts in the subjective world of consciousness? And again, the only way to ascertain these facts is with statistics. You have to do experiments and do them over and over and over again until your probability that you're just lucky or a good guesser, is very, very, very tiny compared to the probability that actually something is to it. Just like the statistics that you have to do in medicine, it's the same sort of thing. So for 35 years, I'm exploring consciousness, trying to come up with what are the facts of this consciousness system. What are the facts? Are there any facts? And that was my mission pretty much from when I first got to Monroe Laboratory. Because I'm a physicist, I want to know what the facts are. How does it work? Well, I found out that there were a lot of facts there. There are facts that explain things that also happen here. So there's connections between the consciousness realm and the physical realm. And you can find things that then you can trace from one to the other, connections between them. Okay, like remote viewing. When you remote view, you can remote view things that are in the physical world. So then you can check. And was what I saw, you know, at the coordinates I was given, that's what's there. Or in the box, you know, what was in the box or what was written on the board. When you're doing these things, you are working in that non-physical space of the larger consciousness system, but you are also interacting with the physical world where you know, the objective side of it where you can go measure. So there's lots of cross-connects between the non-physical, more fundamental space and the virtual reality that it created, okay, for its consciousness entities to make choices in. Okay, so that's the space that then I investigated. I didn't just go strange places that didn't have anything to do with here because there's no evidence involved in that. You have to do evidential things. And I did come up with a pretty large set of facts. You know, remote viewing is a fact. You can get information about what is someplace with your intent. That's a fact. You can get information about individuals. You know, their emotions, their feelings. You can get information about history, things that have happened. Okay. You can get information about the probable future. So there's lots of places where you can get information, and you can use your intent to modify probable future. Now, all of these things can be done and repeated to the point that they become facts. That the statistics that says all of these things can be shown to be subjective facts by statistics. You just have to do them and do them again and do them again and come up with some measure of the uncertainty involved. And when that uncertainty gets smaller than, say, 1 in 1,000 or 1 in 10,000 or sometimes 1 in 100,000, then you've got a very strong subjective fact. Okay? The statistical significance is, you know, 1 in 100,000, say. That's a very, very strong statistical fact. Not that it has zero uncertainty. Nothing has zero uncertainty, including the objective world does not have zero uncertainty. But it has a very small uncertainty, just like the objective world has a very small uncertainty. So it's a fact, subjective fact, just like there are objective facts. And they're both facts by the same, for the same reason, that the uncertainty is very small. That's what makes them a fact. Okay, so I did that. And I had all of these facts from the larger conscious system that was part of the consciousness world. And I had facts, because I'm a physicist, about how the physical world works. That's what physics is all about, learning the facts of that objective reality. And I generated my model to explain all of these facts, all the subjective facts and all of the objective facts. It had to explain all of these. Okay? One of the facts that it explained, my model explained, turned out to be basic physics. You know, why should particles be best described as probability distributions? That's because that's what they actually are. If you look at it from the virtual reality, they are probability distributions. And it's not that that's a good model for them, that's just what they are. So it not only explains things like remote viewing, but also the placebo effect, the power of positive thinking, how you can modify the future reality. And experiments can be done that are very decisive and very clear with good protocol to make these facts. Okay. So it also can explain the paradoxes that are all through physics. There's a lot of paradoxes in physics, things that physicists just don't understand. They know they're facts, but they don't know why, have no idea why it should be that way. One of them is, where did that ball of plasma come from that started the Big Bang? Well, that's a paradox, because our reality didn't exist yet. So it had to come from outside of our reality, and that's as far as anybody gets because they don't know where to go after that. You see, like Einstein didn't know where to go with consciousness because there just wasn't any way to get a grip on that. So that's a paradox. Why is the universe expanding and actually the expansion is accelerating? It's a fact. But they really don't know why that is. They make stuff up. You know, they'll make up, you know, dark energy and so on. That's what's pushing it. But, you know, that's invisible stuff that you can't see, can't smell, can't measure, you know, and that's sort of like fairy dust, you know, you can do that, but they really don't know why that is. There's a lot of others. There's a thing called the Zeno Effect, where depending on how you measure things, you can make things stick in particular states for a very long time when they're really should be changing state because they're an unstable thing, like an atom decaying or something. And the model I have, which is a model of consciousness, explains the Zeno effect. It explains the ball of plasma. It explains why C is a constant. It explains a whole lot of things, and there's a dozen or so of these paradoxes in physics, and it explains all of them. All of them can be explained from a virtual reality perspective. We have those facts. Now these are objective facts that are unknown how they work, that this subjective science is explaining, you see. Also, there are a lot of these facts in philosophy and in metaphysics and in theology. Metaphysics is broken into epistemology, study of knowledge basically, and ontology is being, and then cosmology is how does it all fit together. And metaphysics has been called metaphysics and not physics because there's so much uncertainty about the answers. You know, they're all paradoxes. People can't really get to the root of saying, oh, this is, you know, the fundamentals of being or epistemology or even cosmology. And because they can't, there's a lot of arguing about it, but they can't really come to the conclusion. They're paradoxes. Theology, of course, the big paradox is God, right? I mean, that's a big paradox all by itself. And so on. So we have all the paradoxes that are known in our objective world, including those in philosophy. Philosophy, let's say ethics, that's a part of philosophy. Okay. Many philosophers, the big guns in philosophy, have tried to write a moral code. What's moral, what's not? Or an ethical code. What's ethical and what's not? And they've all failed because they've all got to a point where they say, okay, here's my ethical code. This separates the ethical from the non-ethical. Just follow these rules and you'll be ethical. And what they'll find out is there's always somebody can come up with a good example that their rules fail. They can't meet all the conditions of all the possibilities. They always fail. I think the last really good one was Spinoza did an ethical model, and same problem. It was a good ethical model, but it got to the point that you could come up with good examples that showed that the model failed. Well, this model of mine produces an ethical model that doesn't fail. It meets all the conditions all the time, you see. So that's just another one of these facts. So let's see how these two models hold up. Which one is the better model? Okay, the model from MBT answers all the facts that are in the subjective world and solves all the paradoxes that are in the objective world. The model that we are self-sufficient avatars and our consciousness comes somehow out of our avatar body, and there's a big somehow there that's called the hard problem in science and in consciousness studies. So it's unlikely that that somehow even exists, but we're not going there. We're saying, give them that. Let them have their somehow, and their somehow just magically occurs. Even if there somehow magically occurs and this consciousness is somehow produced by the body, presumably the brain, then what does it solve? It doesn't solve any of the remote viewing. It doesn't solve any of the metaphysical problems. It doesn't solve epistemology. It doesn't solve ontology. It doesn't solve the placebo effect. It doesn't solve, all of the facts that are over on that side. And it doesn't solve why particles ought to be probability distributions. It doesn't solve, where the Big Bang came from, where that ball of plasma. It doesn't solve any of those paradoxes. It only solves one thing, and that is that it says that this is an information-based reality. It agrees with that. And there are a lot of experiments that show that this is an information-based reality. Starting with the double slit. They show that materialism doesn't work. It's about information. So we know that, and this other model that has consciousness that is embedded within the avatar, it solves that. Because it gives us the virtual reality, but it doesn't solve any of the rest of the stuff, you see?
Doesn't answer any of
so
the other questions.
You got two models, and one of them will answer one question, which is, yes, this is a information-based reality, but it doesn't answer any additional questions.
No.
So the other one answers all these other things.
But you did have an advantage over Einstein in that he suspected consciousness was at the root of reality, but he did not have the means at that time that you did with your experiments at the Monroe labs, along with Dennis.
Exactly.
And your expertise in consciousness exploration.
Exactly. It takes both. There's no way that you could write the MBT model of reality without having had a lot of experience doing experiments, really, in what we call the non-physical, which means in consciousness space. So that was necessary. Now that is all subjective. And some people will say, well, none of that stuff exists. There is no remote viewing. There is no placebo effect. All that stuff is just made up. Well, and if it's subjective, then it obviously isn't true. It's somebody's imagination. Somebody's having a problem making stuff up. But now here's the answer to that. And that is that anybody who has that opinion that anything subjective is obviously wrong, they just need to get out a little more. And I don't mean out of their body into the larger conscious system. I mean they just need to go out and look at the evidence that's there. There is plenty of good quality scientific work that has been done over and over and over again. All the stuff that was done at Duke, the stuff that was done at Pear Labs, the stuff that's been done by Dean Radin. There's lots of stuff, and that's just the tip of the iceberg. You will find lots and lots of good data and good experiments done carefully, which is the kind of experiments I did. I didn't just try to heal somebody with my mind once and it worked, and then I thought it was it was true. You have to do that 1,000 times because there's a lot of other variables involved.
And when you say heal, you mean you are interacting with the information. You are using
I'm interacting with the information that defines their physical body because it's a virtual body. Yes, and you do that because you can modify the probability of the future. You can modify the probability. You can't just make the future be whatever you want, but you can modify the probability. And that's all you're doing. And that's it's one of those facts that I discovered that just is a fact. Now, thousands of other people have also discovered that fact. It's not like, I'm the only one. All of this stuff has been known for a long, long, long time. Okay, but once we got into the age of materialism, we kind of let that go because that wasn't in the objective world, and science is all about the objective. So we kind of threw away all those subjective facts because they were kind of scattered through thousands of people and thousands of years, and it really wasn't very well put together. It wasn't a very convincing story. So we kind of dismissed it. But that's why I spent 35 years studying it because I'm kind of hard to convince, being a scientist, and I wanted to be convinced of what those facts were. So that's the difference. You have two models of virtual reality. One basically has our future selves, and that's a default because they couldn't think of anything else. It's the only thing that makes sense to them. And then mine, which basically comes from the larger consciousness system, and we are subsets of that system, and we're playing avatars, dumb avatars. All avatars are dumb, in the sense that your elf is not a smart thing. Your elf is just a little cartoon, on your screen, and doesn't really, think or make choices. You, the consciousness, have to do all the thinking and make all the choices for it. So that's the two separate models. And why can't they both work? Well, I think there's a lot of good reasons why the model that works from our future selves has logical problems with it. And we talked about that last time. It has fundamentally logical problems with it that just don't add up. But in this discussion, we're giving them all that. We're saying, okay, if all of those logical problems are somehow overcome by their magnificent knowledge of the future, then how does it stack up? How does that model stack up against the MBT model? And the fact is, that model is very poor. It doesn't do 1/100th of the explaining that the MBT model does.
Doesn't answer the questions.
It doesn't answer the questions. It doesn't solve the paradoxes. It doesn't explain the things of our experience. And remote viewing is part of our experience. And if you doubt that, just Google remote viewing. Spend a week or 2 weeks around the remote viewing community, and you'd have to be an idiot not to realize that that's hard science. You got a lot of people doing things under very strict conditions, and it just is a fact. It's a it's something that not only is possible, but there's lots of factual material there.
Of course.
So if you've never done it, and all you hear is the materialist side being negative about it, well, the materialist side will say, oh, that's impossible. None of that stuff actually works. Nobody's ever remote viewed anything. That's just all hoax. Those people are all, making that stuff up. These are materialists who have not spent any time looking at the data. They just know it has to be false because it violates their belief in materialism.